Okay, we're going to do some exponential growth and decay. We've got some equations here, and the deal is with each of these situations we want to say whether or not it's growth or decay, and we want to tell the percentage of growth or decay, or the percentage of increase or decrease. So on this first problem, this 2,000 represents the starting amount. That's the amount of whatever this thing represents, how many there are to begin with. The 1.3 is the growth or decay factor, and since that's over 1, greater than 1, it's a growth. So this is exponential growth. And the main thing we want to look at is how far this number is over 1. So 1.3, we would subtract 1 from it and get 0.3, and then we want to change this thing into a percent, and so we'd move the decimal 2 places over, and this would become a 30%, and it's an increase because it's a growth. Okay, y equals 250 times 0.9 to the x. This is has a starting amount of 250 items or people or things or whatever this is. So we know this is a decay because 0.9 is less than 1. Okay, when it's less than 1, we actually want to find out how much less than 1. So we're going to take 1 minus 0.9, and we're going to get 0.1. Then we're going to need to change that into a percent, move the decimal 2 places to the right, and we'll get 10%. So this is a 10% decrease. It's a decay problem. Notice on the growth, we're subtracting 1 from them because we want to know how much above 1 they are. And when we figure out it's a decay problem, we want to subtract that number from 1 to see how far below 1 it is. Essentially, your percentage of decrease or increase is how far away from 1 you are. So on these bottom problems, we have this one's 1,500 for the starting amount. 1.02 is greater than 1, so this is a growth problem. And 1.02 minus 1 is 0.02. If I move the decimal 2 places over, then I would get 2% increase. This problem has a starting amount of 5,000. So because this number 0.25 is less than 1, this is going to be decay. I'm going to take 1 and I'm going to subtract 0.25 from it and get 0.75. That's how far it is from 1. And I'm going to move the decimal over 2 places, and I'm going to get 75% decrease. Okay, so how does this come up in a problem? A lot of times they'll give you some sort of a situation and you have to figure out how to write an equation that models that. This says a stock price at $35, that's the starting amount. So let's plug that into the starting amount. It increases at a rate of 7.5% per year. Okay, so we're going to do exactly that last work we just did backwards. I've got 7.5%, and if you notice before, that number that went in this spot right here, we took it, found out how far it was from 1, and then we moved the decimal over 2 to the right to change it to a percent. So this 7.5%, I'm going to want to move the decimal back 2 places to change it into a decimal. And in doing that, I'm going to get 0.075. Now, that 0.075 is how far we are from 1. And since it's an increase, it's increasing, this is exponential growth, it's going to have to be 0.075 above 1. So that makes this 1.075. If this thing said decreases or decays, then we would have had to take 1 and subtract 0.075 from 1. Okay, to the x power. So there's a function that models the situation. Now they could ask me various things. They could say, hey, how much money would you have after 10 years? And you could put 10 into this x because that x represents the number of years. And the y would then give you how much money that you would have at that time. They could also say, hey, how much or how long would it take to get this $35 to end up being $200, and then you would put $200 in for this y, and then you would solve this exponential equation and find out x, and that would tell you the number of years it would take to get that much money.